So we'll start our finance unit by looking at some savings, and eventually we'll be looking at different savings plans, different types of interest. Here we're going to look at the difference between simple interest and compound interest. We'll look at the differences between the annual percentage rate and the annual percentage yield. Eventually in this unit we'll go on to talking about planning for retirement, so the impact of saving a little bit every month, and so we're going to look at a variety of things. But first we're just going to start by talking about two really important concepts, and one is simple interest and then the other one compound interest, so just different ways that interest is sometimes calculated and computed. So simple interest is where you only earn interest money, so where you earn money only based on the initial amount of the investment. And so that's what we're going to kind of look at first through an example. So if we have example 1 there, it says how much interest, if you suppose you have $1,000, you're going to invest at interest rate of 4% interest per year, what we'll call an annual percentage rate. How much will you have in interest? So basically, how much will you make at the end of the year if you earn 4%? So essentially, all we're really trying to determine here is, basically just, what is, 4% of that $1,000. So we're just trying to determine what 4% of 1,000 is. So of course we know 4%, if we were going to do this computation, we'd have to think of the decimal 0.04 of in math, multiplication, so of that $1,000. And if we multiply those two together, we get $40. So that's how much we would make at the end of the year. So now suppose that that's how much we made, and they sent us that check home, that $40 check, they sent us that home at the end of the year. But that $1,000 is going to continue to earn interest in this same way. So each year it's going to earn $40 a year. So then if we were to look at what we would have at the end of 5 years in terms of how much we would have made in interest, we would have that $40 times 5 years. And so we would have made $200 at the end of that 5 years. So this is what is referred to again as simple interest. So with simple interest, you are only earning interest on the original amount of the investment. So you only make money on the original amount of the investment, which is also called the principal. So that is what simple interest is all about. All right. Now, and there are some things that function this way. A lot of bonds, treasury bonds and things like that will have this type of interest, what we call simple interest. All right, so now suppose that instead of like this idea of a check being sent home in the mail, so suppose that instead of that, suppose that they were to take that, let me erase that because it just looks so sloppy. Now suppose they were to take that $40 and instead of mailing it home to us, suppose they were going to just deposit that into my account. So we're going to look at what that would do and how much we would have, how much maybe we would have made in 5 years. So we're going to model this in Excel. So you can see over here, I already have the beginning of my spreadsheet set up. And so this is going to be, there's a lot of ways we could model this in Excel, but this will be how we kind of model a lot of things. So we're going to start off and we have this first year, and what we start off with is our beginning balance is going to be 100. Now notice right now, I already have my cells formatted to currency. It's not imperative, but it might just look a little nicer as we're doing our work. So if you want to just highlight, let's say on columns B, C, and D, and then up here at the top in this little drop-down menu, yours might be on general right now. You can change it to currency, and then all of these cells, when you tap on them, you notice that they're set to currency, as opposed to in my first column, I didn't do that, and they're just a general formatting. So it's up to you. All right, so let's go ahead and start with our beginning balance of the 1,000. All right, now interest. Okay, we're doing this same computation. It's 4% at the end of the year. So we're going to go equals, and 4%, just like we did in number 1, so 0.04 in its decimal form, of, so times, but rather than typing in the number 1,000, that's where we want to do our cell reference. So tap on cell B2 or type in B2. That way we're going to be able to model this for many years. And then hit enter. So yeah, I made $40. Okay, but now instead of the bank just sending me that check home, they're going to add it into my account. So now my new end balance is going to equal the beginning balance, cell referenced, plus the interest I made, also cell referenced. So now that's my end balance at the end of that year. And of course, that's what I'm going to start year 2 with. So I'm going to start the beginning of year 2 equal to the end of where I ended at year 1. And so once we get to this point, we can go to these last cells we've just put in, and we can click and fill. So double click or click and drag. So hover in the right-hand corner. Now things are going to look a little weird until you get everything filled because they're cell referenced on cells that haven't been filled yet. So again, we can fill, because we have a formula there, the interest, and we can fill the end balance because again, we have a formula in there. Once you get done, then everything will fill. So here's what I noticed. At the end of the 5 years, we have an end balance of that original $1,000 principal, but now we have an extra $216.65 as opposed to just the $200 we made over here if they just send us $40 home every year. If they put that back into our account, what happens is we get to make interest not only on the initial balance, like that $1,000, but we're also making interest on the interest from the previous year. And that happens every time. So this is what we call compound interest, where you get to make interest not only on your principal, but also on the interest that you've earned. So you notice that's exactly what we have here. Again, here's our definition for compound interest. So when you think about which is, better, well, obviously we made more money with compound interest. So compound interest is going to earn you more money. Now, you may wonder, which type of interest is typically used. Both get used. More often than not, banks and other investments and things will use compound interest, but there are certain types of like savings bonds that might have certain benefits to them, like a guaranteed rate and certain tax benefits. And so a lot of times those savings bonds might pay simple interest. And so, you definitely see both done out there. So let's continue talking about compound interest in a little more detail here. So now suppose that instead of the bank calculating interest once at the end of the year, like we modeled over here, now suppose that they say, okay, we're going to still pay you that annual interest rate of 4%, but we're going to calculate your interest quarterly. So that's what is when we say compounded quarterly. That's going to mean 4 times a year. So compounded quarterly means they're going to calculate in my interest 4 times a year. Now, it would be lovely if 4 times a year they gave me 4%, but that would be more like 16% that they would have given me annually. They're only giving me a 4% annual yearly interest rate. So they say, okay, we're going to take that 4% and we're going to divide it by the number of times that we are going to calculate and give you some interest money, which in this case is 4. So 4 times a year, so about every 3 months or so, they are going to give me 1% interest. So let's take a look at what that would look like in Excel. All right, so again, I'm going to go over here to I have this one kind of set up. The only thing that's going to change now is instead of a year, this is going to be a quarter, beginning balance, interest, and end balance. And so here's what we need to be mindful of. 4 quarters is going to be 1 year. If I want to actually compare with what we've done previously, which is what happens after 5 years, I'm going to need to go to 5 years times 4 quarters in a year would be 20 quarters. So remember to get a quick list of numbers in Excel. This is where you can do your little double highlight 2 numbers at once, and then hover in the lower right-hand corner over that little green square, and then pull down, and Excel will just pick up on whatever number pattern you want, and you can extend it until you see that little gray box go to 20. This is the only time you should be doing the double highlight and filling, is when you want to create a quick list of numbers. That is not what we do if we've come up with a formula that we've typed in with cell references and things like that. All right, so again, we're starting with again, if you want, I've already done it here. You can highlight on the columns that's going to have money in it and change it to currency. Sometimes it's just easier to look at. So let's start with our beginning balance of 1,000. Now here's what you have to remember, and by far it's the easiest thing to forget. You're reading the problem and you see that it's equal to, and you think, oh, interest is 4%, so I'm going to go 0.04 times my beginning balance. The problem is that's what we do for an annual. This is only the first quarter. So we have to take that interest rate, that 0.04, and divide it by 4. And yes, that's simple arithmetic, that's just 0.01, but I want you to get into the habit of doing that in Excel and leaving that set up for like the full division answer to be in Excel that way. So the 4% divided by the number of compoundings. So that's key. So that means that in the first quarter, so basically after 3 months, I earned 10 bucks. Again, end balance at the end of that quarter is beginning balance plus interest, cell referenced. And then we start our new quarter equal to the end of our last quarter. Now that we have all that, we can go back to the last 3 values we've just done here with formulas, hover in the lower right-hand corner and double click, or click and drag if you prefer. And again, it takes a minute for everything to kind of fill in because of all those empty cell references. Once we do, let's scroll down to see that after 20 quarters, which is really 5 years, we now have an end balance of 1220.19. So notice that that is definitely better than 1216.75. Both of those were an annual interest rate of 4%, but this second one we just did, that was when interest was compounded quarterly, we made a little more. So when you think about the difference between interest being compounded annually or quarterly, it should be clear after kind of doing this example that the more compoundings, the better. So essentially, the more times that they stop, they figure some interest and add it into your balance, that base amount has gotten bigger. And so the larger that base amount is, then that's going to lead to larger interest amounts. So the more often that they do that, the more beneficial it is for an investor, for us, if we're saving. So again, you'll see all different types as we go through the section and just in general of compoundings. Annually would be once a year, semi-annually is twice a year, quarterly will be 4 times a year, and monthly will be 12 times a year. So we'll have to kind of be on the lookout as we're reading these problems and kind of thinking about which we're being given. So what we've been looking at here so far, that 4%, that annual interest rate, that annual percentage rate, also sometimes called the nominal rate. This is what Excel will refer to it as when later I show you an Excel function that will do this work. That's this 4% that we've been discussing. That's the annual percentage rate or the nominal rate. Now, here's what's interesting. I just did, a few examples, all involved 4%, but all of them earned me a different amount of money. So when we think about an annual percentage rate or a nominal rate, that only tells part of the story. The rest of the story, in terms of how much money I'm going to make, is going to come from how often the interest is compounded. That affects how much money I make. So again, when interest was compounded annually, I just made the $40 after 1 year. When interest was compounded, let's go back to the first spreadsheet, quarterly, that was this one. So when interest was compounded quarterly, I made $40.60. Look at the end of the fourth quarter there. That's 1 year right here. And so I made $40.60 when interest was compounded quarterly. So in order to kind of look at what's the true percentage that I actually yielded, that's going to be what we refer to as the annual percentage yield. So when I think about that here, like in this example, if I kind of off to the side, open, or just start with a little equals sign and open a parenthesis, if I think about percent change as good old new minus old over old, so remember percent change, new minus old, change in value over the original value. So when we think about that, let's think about what percent I earned in this quarterly situation. So the new balance was this 1,040.60 minus the old original balance at the beginning of the year was the 1,000, close parenthesis, divided by that 1,000, that's that old original value. So new minus old over old. Oh, I don't love that let's go back to general on that. Don't want that to look like currency. But let's make that into a percent and tack on a couple of decimal places. So what we just saw here is that when interest was compounded quarterly, I actually made 4.06%. So I made 4.06% is what I actually yielded. And I keep saying that word to kind of lead us somewhere. So this percent that we actually yield in a year, so what we actually yielded in, and this is crucial, in 1 year. So I want you to think about that word annual, it means 1 year. So that is what we refer to as the APY, the percent we actually yield in a year. So when interest is compounded more than once a year, the APY, which is also in Excel later we'll talk about, sometimes called the effective rate, that will be a little bit higher than the APR. All right, so let's look at just a few kind of observations about these. So the APR is sort of the advertised often interest rate, and it's what the annual interest rate is without taking into account any type of compoundings with the compounded interest. The annual percentage yield, sometimes called the effective rate, is the actual percent that your balance changes in a year. So it takes into account, another thing, it takes into account the compounding of the interest. So think about what we just did right here. So some observations. So first of all, your APY is your change in balance over original balance, or the amount that you earned in interest, which was the $40.60, divided by the principal. So the key here is, again, keeping in mind this is not just the change in balance over the whole investment, but over 1 year. So as you're looking at this, make sure you kind of realize that the A in annual is really just over the course of 1 year. So when you're computing your APY, if I ask you to compute it, let's say by hand, like we just did, yes, it is definitely this change in balance over original balance, or amount earned in interest divided by the principal, but over the course of just 1 year. So notice on this example, I didn't go all the way down to the end balance of the whole investment when I was computing this APY. So when I did that, it was just looking at what I had made over the course of that percent change over 1 year. So some things that we want to observe. First of all, if interest is only compounded annually, the APY is equal to the APR. So if we went back to this first example, we modeled 5 years, but interest was only determined or calculated, I should say, once a year. So if I did the percent change, it's still over 1 year. So 1040 minus 1,000 divided by 1,000, that would be 4%. So if interest is only calculated annually, then your APY will equal your APR. If interest is compounded more than once a year, and so a lot of times, quarterly, monthly, something like that, then your APY is going to be a little bigger than your APR. Okay? But again, I'm going to emphasize when you kind of look at this right here, let's just sort of say off to the side here, it's just going to be a little bigger, right? So we just did an APY that was 4.06% as opposed to 4%. That's reasonable for an APY. What we don't want to ever get is if I would have gotten 40.6% when the APR was only 4%. It should be like decimal values bigger, just a little bigger than the APR, not much, just a little bit. And neither of these, the percent that you're making, neither depend on the principal, the amount. The percent is not impacted by that. So we want to make sure that we know the difference between these two. So we're going to look at a few scenarios, maybe where one is published in one way and another banking situation publishes it in a different way. So when you're comparing two different accounts, as we look at these, the safest thing to look at is the APYs of both, because that is the percent you will actually yield. All right, let's look at this first example here. Example 4. You have a choice between two different savings plans. First one has an APR of 5%, interest compounded quarterly. The second has an advertisement of compounding semi-annually, that's twice a year, and an APY of 5%. So here we don't actually need to do any computations to determine which is better. So first of all, at first it sort of feels like, well, quarterly, that's 4 times a year, semi-annually is twice a year, and there's somewhat of a natural instinct to want to go with quarterly. And that would be true if both of these were advertising the APRs, but they're not. One advertises the APR, the other advertises the APY. So if we were to think about kind of both of these situations here, so if I had this first account and it has, so we'll say like the first account here. So suppose the first account, it has an APR of 5% and interest is going to be compounded quarterly. And so what that tells me is because it's being compounded more than once a year, here's what I know, that the annual percent that I actually yield is going to be a little bit bigger than what the APR was, which was 5%. Now, in the second account, they didn't tell me what the APR was. So, that I don't really know. So if I think about the APR, I don't really know. They did tell me that it was compounded semi-annually. But at the end, whatever that ends up being, they have told me what my APY is. They have said that the APY, the percent we actually yield, is going to equal 5%. So in some ways, it doesn't really matter that they didn't give me the APR of the second account because they have told me what its APY is. So if the APY of the second account is 5%, and I now know that the APY of the first account is going to be a little bigger than that 5%, this is then telling me that the first account is going to be better. So this tells me that the first account is going to be the one that actually yields me more money. It has a higher APY, and that's what we really want to focus on. All right, now it says example 5. Suppose that in the previous example, the second bank says that they have an APY of 5% with interest compounded monthly this time. Would that change my answer? It would not, because the second one's APY is still 5%. The fact that it compounds monthly, I mean, that's great, but they've already told me like the end result. So however interest is determined, monthly, quarterly, daily, they'd be whatever it is, they've already told me the percent I would actually yield. So at the end of the day, no, because it would not change what that APY is. So in this situation, we would say no, it would not change my answer because they gave or were reporting the APY. So they were already giving me the end result. All right, number 6. Now suppose we have two choices. First one is an APY. So again, I'm getting the end result of 6.05%. That is the percent I am yielding, and interest is compounded monthly. Okay, so whatever the APR is, it's something under 6.05%. They're going to calculate interest every month, but the percent I will yield is 6.05%. Now, the second account advertises an APR of 6% and interest is compounded monthly. Well, this one is going to require that I actually do some computation here, because while I know the APY of the first account, so that's important to look at, is the fact that I know the APY of the first one. So the first one, I already have its APY. But on the second one, all I really know is that the APY of the second account is going to be higher than 6%. So in the second choice, we just know that the APY is going to be a little higher than 6%, and that is because interest is compounded monthly. So because interest is compounded monthly, we know that its APY is going to be a little bit higher than 6%, but we don't know how much higher. Maybe it's going to be just 6.01%, maybe it'll be 6.1%. But I know it's a little higher, but I don't know how much higher, and so I won't know how that's going to compare with this first bank's APY, right? So the first bank's APY is 6.05%. The second APY is going to be a little higher than 6%, but I don't know how much higher. So this is a time when I actually have to do some work to figure out what the APY of the second account is. So that's what we're going to do here. All right, so let's, over here on the right, we have our spreadsheet set up. So I have month, beginning balance, interest, and end balance. Here, I only need to extend my spreadsheet for 12 months because I just really want to know what will I have at the end of 1 year. And I can really start with any balance I want. In fact, you want to start with $53, you can do it. But a nice even beginning balance to start with is $100, but you could start with anything. Now, my interest on this account is equal to the APR of this second account is the 6%. So this is going to be, now up until now, I've always been just converting it to decimal form, so 0.06. That, of course, will work. But your other option, just to kind of mention, if you're ever a little nervous, like, did I get the right number of decimal moves, or if you have an interest rate that has a lot of decimals itself, Excel knows what the percent symbol means, so you could type in 6%. So that's kind of up to you. But don't forget, this is the thing in class, my next question if I was in class would be, what do I need next? because interest is compounded monthly, we got to get that divided by 12 in there. You know, they're not going to give me 6% every month. That would be great. That would be like 72% at the end of the year. But they're going to give me 6% divided by 12, so they're going to give me like a 0.5% per year, or sorry, per month. So that's the percent, but you leave it in Excel like that, and then times beginning balance. So 50 cents is what I get at the end of a month here, and my end balance is going to be my beginning balance plus my interest amount. And then my new beginning balance is equal to my old end balance. And just like we've been doing today, once we get those values, we will fill our spreadsheets. And now, at the end, so if you're pretty good with percents, remember percents are always based on 100. If I go from 100, which is what I had here, is my beginning initial amount, and I end at 106.17, that's going to be a 6.17%. But let's actually compute it. So here's how, when I ask you to compute the APY, and I might say something like utilizing a couple of cell entries or utilizing a couple of values from your spreadsheet. When we did it for compounded quarterly, the end of 1 year was the end of the 4th quarter, but it was new minus old divided by old at the end of the 4th quarter was the end of 1 year. This time we're computing it after in 12 months. So we're going to say this equals, open parenthesis, the end balance after 1 year minus the beginning balance at the beginning of the year, close parenthesis, divided by the beginning balance at the beginning. And so again, let's take that, I don't want that on currency, just general. Percent, and let's tack on a couple of decimals. So 6.17%. So we have now determined Bank 1 had an APY of 6.05%. We just determined that when interest is compounded monthly, we just determined that the APY of this account is the 6.17%. And recalling, the first APY was 6.05%. The second one now we know as 6.17. Oops, that was supposed to be a 7 in there. 17%. So therefore, we want to always pick the one that has the higher APY. We are yielding, the percent we actually yield is more. So therefore, we choose this second option. So the last part of this little section before the next group activity gives you some formulas. These are just for your reference. Those of you who've had some of these interest concepts maybe in other classes might recognize the simple interest formula or the compound interest formula. I really don't want you to use these in my class. You're going to either be doing Excel spreadsheet, and then later when we get to some shortcut formulas in the next section, it's going to be Excel functions we're going to use. So these are just kind of here as a reference, and sometimes people just like to make the connection with material that they might have learned in a different class. But, you know, like I said, here we're not going to be using these. Like if I ask you to compute the APY and I say utilize a couple of cell entries, it's going to be exactly what we did here as opposed to this formula here. Yes, it would get you the same answer, but I just really want you to have this intuitive notion of a percent that you yield over 1 year, just going back to good old new minus old over old that we've been talking about all semester. All right, so that's it for this one. You're now set to go on group activity 18. And I think in my class, I'm going to have you do all of 18 here. So I'm not going to omit anything from this group activity.